So again, this is another implicitly defined function where we have the y embedded in the equation. So to find the derivative, we need to differentiate this normally and differentiate using chain rule whenever we encounter a y. So I'm going to differentiate this normally. So I'm going to end up with 6x squared plus, now we have a product here between x squared and y, so I'm going to factor the 6 out. And inside there, I'm going to apply the product rule onto that. So I end up with 2x times y plus x squared. Now I'm differentiating y, so this is where I generate my y prime. And then I encounter y squared, so I'm going to differentiate that normally. So 2y, but because I differentiated the y, I have to apply chain rule and differentiate that inside function y by multiplying it by y prime. And then that's going to be equal to the derivative of -7 is 0. Okay, so now I want to group together all my y prime terms. I've got y prime terms here. So I'm going to group those together, and I'm going to end up with, well, let's multiply this out first. So 6x squared plus 12xy plus 6x squared y prime. So the y prime is what I'm looking for, plus 2y, and there's my y prime. Okay, so I've got a common factor of 2. I really probably would make it easier on myself by dividing everything by 2. So again, keeping track of my y primes, plus y times y prime, and that's equal to 0. So I'm going to group my y prime terms. That all gets grouped together, so I'm going to factor that. So y prime, end up with 3x squared plus y. Okay, so those are my y prime terms. And then on the other side, I'm just going to take these terms to the other side. These terms go onto this side, so I end up with negative 3x squared minus 6xy. And I could factor the x, but I think I'm just going to leave it like that. And then finally solving for y prime. So y prime as a function of x and y. Okay, so I need an x and y to be able to calculate the slope. It's negative 3x squared minus 6xy all over 3x squared plus y. Okay, so I want to find the slope at x equals 1. Well, x equals 1 right about here. Now, it looks like it could be a vertical tangent line. Okay, so that looks very possible that it's a vertical tangent line through there. And to find the slope though, I need both an x and y coordinate. So I have x equals 1, but I need to calculate the y coordinate. I'm going to do that by plugging that back into the original equation. So I have 2x cubed, so 2x cubed, where x is equal to 1, plus 6x squared y, so 6x squared y, which I'm solving for, plus y squared equals -7. So again, I'm just going back to this original equation here, and I'm using that to generate this. And I have now an equation which I can solve for y. So solving for y, it's a quadratic in terms of y, so y squared plus 6y, and then it's going to be plus 2, and I'm going to add 7 to both sides, so I get plus 9 equals 0. I can solve for y by factoring this. So I get y is equal to -3. So at -3, well, it looks like it's right about there actually. Okay, so it's going to be tangent at that point and looking very vertical there. So I've got a coordinate at x equals 1, y equals -3, and using that coordinate, I'm just going to plug that into my derivative. y prime at x equals 1, y equals 3. Okay, plugging that into my derivative, I get, I'm just going to give myself a little bit of room to work here. Okay, plugging that into my derivative. Okay. Okay, so that looks pretty good. So I'm going to plug that into my derivative. So I get negative 3 times 1 squared minus 6 times 1 times 3. I'm going to plug in my values here. So that's x equals 1, y equals 3. And then in the denominator, I'm going to calculate 3 times x squared plus y. Okay, plugging in those values, I'm going to get 1 squared and 3. Now, that's going to be negative 3, plugging in negative 3 here. So when I calculate the slope in the numerator, I'm going to get negative 3 plus 18, so I get positive 15. And in the denominator, I'm going to get a 0. So that means that I have a vertical asymptote. This gives me my vertical asymptote that I see right here.